right now? So I'm guessing there's lots of people at home sitting at their kitchen tables or laying on their bed watching this stream or this video or a different class's stream or whatever, and they are not wearing shoes because I personally prefer not to have shoes on if at all possible when in my house. Not just because I'm cleanly, but because I'm lazy. Okay, a statistic is a numerical description of a sample. See, I also got this highlighter, but it's red, which makes me think it's going to be too dark. Yeah, way too dark. Okay, so this one right here, I'm not going to color over it or you'll never be able to see it, is the same as this one. So a sample and a statistic are related to each other. Sample is part of a population. Statistic is a numerical description of that part of the population. So if I said 70% of the student body are wearing shoes right now, this is my description of my population. I could say, yeah, but 99% of the students that are in the school right now are wearing shoes. In this case, the sample doesn't really match the population. And the reason is because specifically shoes is something that you tend to not necessarily do in your house. Some people do, some people don't. But definitely something you need to do in school. So those are definitely related to each other. All right, I'm going to zoom out a little bit, get a good picture of this so that you can pause your video if you need to change anything on this sheet. We're now done with 6. We've got 2 to go. More than halfway there. Okay, so there are 2 branches of statistics. I'm just going to write that right here. There are 2 branches of statistics. There's the descriptive branch and the inferential branch. Okay, so we've got the descriptive branch of statistics and the inferential part of statistics. So the descriptive part of statistics is basically handling all the data. You're organizing it. You're summarizing it. And you're displaying that data. So it's the organization, the summarization, and the display of data. So let's say that we captured 50 geese. Okay, we captured 50 geese and we took a look at their temperament and to see, you know, if they were just awesome, nice geese or if they were evil, horrible, horrible geese. I mean, this is just a made-up study. I didn't actually do this because I'm not stupid enough to capture 50 geese. But let's say I did, okay? So then I would find that most of the geese here are horrible, okay? So we got a whole bunch of horrible geese, lots of them, and then there's a small portion of, what do you think? You think they're going to be good geese? No, incorrect. This would be unknown, like we don't know what their temperament is because maybe like we couldn't get a good read on them. So we don't know if they're like nice geese or if they're horrible geese. Probably horrible. But we don't know for sure. So we're just going to leave it as unknown. There. I've organized my data. I've summarized my data. I've displayed my data. Descriptive statistics. Okay. Now, inferential statistics is using a sample to draw a conclusion about a population, which is the whole reason why we're doing this. We're trying to be able to look carefully at a small portion and make a conclusion about the whole. So if we go back to my 50 geese example, I think by looking at this obvious chart, that we can conclude that most geese are horrible. Okay, in the whole world. Of course, I'd have to have a good sample. I mean, what if I just took 50 geese from Minnesota? Then I'd have to say that most geese in Minnesota were horrible. But I'm going to assume that this sample that I completely made up here had geese from all over the world, and that most of them were horrible, and we had some that were unknown. So anyway, that's inferential stats. So that's it for today. 8 definitions, no homework. I hope you guys have a terrific day, and I'll see you tomorrow. Bye.